Hello, everyone. Okay, so my name is Gabrielle, and today I'm going to talk about threat hunting in cloud-based environments. So just a quick table of contents so you know what you're getting into. I'm going to do a quick introduction, go a little bit into threat hunting 101, talk about the cloud very briefly, and then talk about some multi-cloud considerations and things along those lines. So as far as an introduction, why am I here? I get asked that a lot. My name is Gabrielle. I have been in the information security field for a little bit now. Started out doing medical device security and vulnerabilities and kind of did a lot of stuff from there. So I did some vulnerability management. I worked as a cloud security engineer at a company that used 5 different cloud service providers, so got really well versed in that. And then currently work as an SE for NetWitness. So I wanted to start off with a quote, mostly because I wanted to use this cool quote slide template, but this is from a good friend of mine, Dr. Eugene Spafford. He said that a system is good if it does what it's supposed to do and secure if it doesn't do anything else. And that always comes back to me. I always end up thinking about that and thinking about how true it is, especially while threat hunting. All right, so threat hunting 101 with a quote from Liam Neeson, because it belongs there. So what is threat hunting? Threat hunting is a proactive opportunity for an organization to uncover attacker presence in their environments. It's an intelligence-driven analysis to determine if and when attackers have gained access to their resources. Attackers can evade detections and bypass alarms sometimes, so hunting is an important addition to any security program. There are a few different types of threat hunting. You can do structured threat hunting, which is a little bit more formal, to search for attackers and tactics that are specifically used by them. You can also do unstructured threat hunting, which is a little bit more free-flowing. It's a little bit more ad hoc. They tend to be a little opportunistic, and they can be a lot harder for newer organizations and newer programs that are trying to build their threat hunting capabilities. They're also situational and entity-driven, which are a lot of times when you find something and you're like, okay, we're going to look more into this, and it turns into threat hunting. So across those 3 different types of threat hunting, there are a few different ways to go about it. There's intelligence-based threat hunting, which is a little bit more reactive. It's a hunting model that uses IOCs from threat intelligence resources or sources, and from there, the hunt follows predefined rules established by your security tools and threat intelligence that you have. A lot of times these intelligence-based hunts, they'll use IOCs, hash values, IP addresses, domain names, networks, or host artifacts that are provided by intelligence sharing platforms. On the other hand, there's hypothesis hunting, which is proactive, and it uses a threat hunting library. So a lot of times organizations will align with MITRE attack frameworks and stuff like that, and use global detection playbooks so that they can identify advanced persistent threat groups and malware attacks. Hypothesis-based hunts use TTPs and things like that from attackers. There's also some custom hunting. You can kind of do a hybrid of those things if you want to, once you get really good at what you're doing, based on situational awareness and industry-based hunting methodologies. So it'll identify anomalies in SIM and EDR tools, and you can customize what you're looking for based on customer requirements. So a lot of the custom situational hunts are based on those customer requirements, or they're proactively executed based on situations. So if you're looking for something related to geopolitical issues or targeted specifically attacks, these hunting activities can draw on both intel and hypothesis-based methodologies. So a hypothesis-driven cycle is oftentimes a lot easier to start with for organizations because it allows you to kind of work through a specific process and just go through the steps that kind of allow you to learn the threat hunting process. So with a hypothesis-driven cycle, we would start with visibility. So that's where your successful hunt begins. If you have really limited visibility, it's going to skew your data and it's going to instill a lot less confidence in your results. Ways that you can improve visibility can be as simple as deploying EDR agents, network visibility aids, aggregating logs, things along those lines. To further this, developing a robust pipeline that enriches data is extremely helpful. It includes things like geolocation, data parsing and standardization, and using threat intelligence feeds. Intelligence analysis is your next phase that you're going to want to focus on. This is when the hunt team works to identify potential threats in the environment and works with key stakeholders to better understand the scope and environment of the hunt. So a lot of times, this is when you'll use an attacker methodology like MITRE ATT&CK to aid in TTP research and develop critical system lists and diagrams that can be helpful during this stage. Hypothesis formation is the third step. That is when you're going to develop hypotheses targeting activities that threat actors might perform in the environment, and they can be used to guide the behaviors that the team looks for during an engagement. Analytic creation is when your team is going to develop specific queries or analytics to identify the targeted threat behavior based on the parameters set in those previous steps. Execution is the fun part. It's when the hunt team executes their test cases and retrieves results for the follow-on analysis. And then finally, investigation and validation determine whether identified activity is malicious. So this is one of the steps where visibility preparation will really pay off if it's done thoroughly. It'll also lead into increasing efficiency and detection rates. Any true detection will also likely be turned into an actual investigation at that stage. All right, so some key threats that a lot of times we're looking for that we see during threat hunting. 90% of cyber attacks are initiated via phishing. This is when, I'm sure everyone knows this, but when email is used as an attack vector to inject malicious code or divert a user to a phony site or false site to harvest credentials, things along those lines. Ransomware is another top threat here. It's obviously in the news constantly. Ransomware as a service is also becoming a really, really big thing. So it's a lot more accessible to groups that might not have been able to use ransomware otherwise. Nation-state actors are attackers that are often motivated by politics and nationalism. Based on the political landscape, you will see more or less of those. And finally, insider threats is continually being talked about more and more. It's a lot of times when people are using their authorized access or knowledge of an organization to harm that organization. So something that you might not see on this is misconfiguration and a lot of things along those lines that contribute to the vulnerabilities in cloud environments. Because I would say that when you look at a cloud environment, your number one issue is going to be misconfiguration or something along those lines. But that kind of takes us into when is a threat a threat? So when we're threat hunting, we're looking for a very specific threat. So much like a crime, a threat has very clear parameters to meet in order to be considered as such. So very similar to what you might see in criminal justice, means, motive, and opportunity is what makes up a crime. And it's also similar to what makes up a threat. So means is your way to commit the crime or do whatever you're trying to do. Motive is your reason, why you're going after what you're going after, why you're doing what you're doing. And opportunity is your chance to commit the crime, your chance to infiltrate whatever. All right, and then the hunt. The hunt needs a plan. I mean, we went through that methodology really quickly. That just kind of outlined what a hypothesis-driven plan would look like, and all hunts need to have some sort of plan. So your purpose, what are you doing? Your location, where are you doing it? Your scope is really important when you're threat hunting because it's really easy to get overwhelmed with everything that you're seeing. And then finally, your outcomes. What do you want to find? You don't want confirmation bias here, but you do want an expectation of what you're specifically looking for. All right, now on to the cloud. It really is just someone else's computer. So how does threat hunting change in cloud-based environments? It is estimated that 50% of the world's data will be stored in cloud infrastructure by 2025. That is 100 zettabytes, give or take a little bit of data across public clouds, government clouds, private clouds, and just cloud storage providers in general. This is the meme that I always think of when I think about the cloud just because these guys are my favorite from Toy Story. So, ooh, the cloud. All right, so your key differences between cloud environments and on-prem environments are going to lie in how information is obtained and analyzed, and the response mechanisms and tools that are used. Those are often very different in cloud-based environments. Also, when you're working in cloud environments, there are 3 fundamental truths, 3 fundamental precepts that you want to keep in mind. So, just because an organization is in the cloud does not mean attackers stop. I don't know how many times I have seen people think that for some reason putting things into a cloud is like putting them in a safe somewhere, but that's not the case. I would say, honestly, in today's landscape, you could be attracting more attackers when it comes to cloud just based on how terrible your misconfigurations are. So, number 1. Number 2, it is really beneficial to your defense strategy to understand adversaries' objectives and the tradecraft that they use to act on them. So if you don't know what you're looking for or what someone might be going after in your system, that's a problem. Number 3, visibility across all layers is super important, even where ops management is on the CSP side of the shared responsibility model. So you need to visualize as much as you can in your environment. You don't know what you don't know, to quote one of my fantastic coworkers. So what is that shared responsibility model? This is one of the weirdest gray areas in cloud environments. It is both very well laid out and also very confusing. So in the AWS shared security model, AWS claims responsibility for protecting hardware, software, networking, and facilities for the AWS cloud services. Azure, Microsoft Azure, claims security ownership of physical hosts, networks, and data centers. So both AWS and Azure state that your routine security responsibilities depend on which services that you select. So when you look at the shared responsibility model, the way that I always like to explain it and look at it is, as a customer, your responsibility lies for security in the cloud. As a cloud service provider, whether it be AWS, Azure, GCP, anyone along those lines, your responsibilities lay in security of the cloud. So putting things in the cloud does not make them secure. You need to learn how to configure things correctly and things like that. But it is very important, especially when you're threat hunting and you're looking for certain things in the environment, to know where your responsibility lies in securing your infrastructure. All right, then I quickly want to talk about multi-cloud considerations. That's been kind of a buzzword in the industry for a while now, and I know we all love buzzwords, but it is definitely something worth talking about. So, according to the Flexera 2022 State of the Cloud report, 89% of responding organizations reported having a multi-cloud strategy, and 80% are taking a hybrid approach by combining use of both public and private clouds. So you can see here, 89% taking a multi-cloud strategy. I would say that's a pretty big majority. 9% are sticking with the single public cloud, and 2% with the single private cloud. So when you're talking about multi-cloud environments, it's really important to understand what the differences are with these. So there's a lot of differences between cloud service providers, oftentimes in compliance and configuration transparency. There are some things that you can do with AWS that you can't do with Azure, vice versa. Differences in remote data sources and infrastructures. Your infrastructure is going to look different across different cloud service providers. It's just the nature of how things are set up. There will also be a lot of differences in core security capabilities and APIs. And finally, cross-environment analysis and data correlation must be factored in. One of the biggest issues that I've run into, especially when creating, a security data lake based on cloud environments and things like that, is standardization of certain types of data. It's very different all across the board. All right, so steps to take when you are trying to wrangle your multi-cloud environments. First of all, you want to normalize that data and information that flows between the multiple environments, including cloud service providers and any on-prem environments you have. Try and find a way to standardize that data as much as possible. You also want to understand the events that happen across environments. Sometimes they can look different, but they're actually the same type of event. Number 2, understanding systematic threat modeling. So taking attacker's view of the application can really help you develop hypotheses and threat model a little bit better. So again, it comes back to the psychology of the attacker. What are they looking for? What do you have that would be valuable to them? Number 3, education. So you want to understand what you have and how it fits together with each other. If you're duplicating a lot of things from cloud to cloud, that could be a potential issue down the road. You also, step 4, want to actualize. So you want to connect everything into a narrative. How does it all connect together? How does it work together? And how does it support each other if you're using separate cloud service providers and different services across those providers? So as far as building a threat hunting program, there's a lot of different, levels of threat hunting that you can get into, and it really depends on the resources that you have and the people that you have and the tools that you have, and there's a million different things that can factor into it. So as far as, I think that following a maturity model like this would actually be really beneficial, because you are not trying to have the most advanced threat hunting program on day one. You can try, but it's gonna be really hard. So, there's unfortunately a lot of places starting on this model that don't have a threat hunting program, whether it's lack of resources or just, I don't know the reasons. It makes me sad, but I get it. Everyone starts somewhere. So there's also, if you're gonna start out, I think an initial level of threat hunting is a good one. So relying on automated alerting tools and correlating tools. So being able to see how your data fits together, things like your WAF, your antivirus, your IDS, your SIM tools, just kind of figuring out what pieces each of those grabs and putting them together. There's not a lot of hunting in that stage. It's more of getting your visibility on point, kind of like talked about earlier, where you really need to understand what everything looks like and see that total landscape that you have. If you move up a little bit, you've got your minimal. That sounds kind of offensive. I don't mean it that way. But your IT data is included for your daily activity. So you've got all your IT data, you've got all your visibility set up, you can see everything. You can start leveraging your threat intel feeds on any of the tools that you're using and correlate a lot of the data that is fed to your tools. So you're starting to kind of understand the landscape. Okay, these are the threats that tie to the things that I have going on right now. Next up, procedural. Again, a little bit more advanced. Your analysts and researchers at this stage are developing a lot of procedures at this point, threat hunting procedures, things like that. A lot of times, though, it is limited to known or published ones. So it's, procedures, playbooks that other groups are using and things like that. Once you get up to the innovative stage, that's where a lot of things get super fun. You can start obtaining data and using data visibility and machine learning to develop your own procedures. This stage does get a little bit hairy because as you're starting to standardize things from multiple cloud environments, it gets a little crazy. There's a lot of scale to address and deal with, so it is a rough stage to be in. But if we want to look at the utopia of threat hunting, that would be the leading stage of the maturity model. So at the leading stage, you would have the ability to automate repetitive processes, so you're not wasting your time on those, tune existing processes to make them more efficient. You'd be able to dedicate more time because of that to build your own processes. You would define your metrics, so KPIs and SLAs are super important once you get to a mature threat hunting model. Automated risk scoring, again, is fantastic. It takes some of the guesswork out of things, and if you can just correlate data into a single risk score, that'll be super helpful in not having people, comb through some of the lower level data. Horizon scanning, again, super helpful. Regular hunts, also super helpful. If you can get those done pretty regularly, start adding in new procedures that you've come up with, processes, things like that, that'll be really helpful for your threat hunting program. And finally, high data visibility, whether it be a security data lake where you've got a bunch of stuff where you can manipulate data to look at it, or anything across those lines. Data visibility, I think, is one of the, if you take anything home from this, take home that data visibility is important. And with that, that is it. I am a little short, so if anyone has any questions, I'm happy to answer them.